The purpose of this video is to learn how to calculate a confidence interval for two population proportions. In this example, we will analyze the effect of sleep on mental performance. We have 100 volunteers that were divided into two equal groups of 50 students. Each student or volunteer took a math test that involved transforming strings of 8 digits into a new string of numbers associated with a specific criteria. The difference between the two groups is that one group of 50 volunteers had 8 hours of sleep before taking the test, while the other group stayed awake all night. The question we're being asked from the study, what can you infer about the proportion of volunteers in the two groups who successfully transformed the numbers per said specific criteria? And then support your answer by creating a 90% confidence interval. So the first group of 50, after a full night of sleep, 39 out of 50 students were able to complete this test successfully, while the group of students that were awake the night before, only 15 of 50 were able to successfully complete the task successfully. So P1 hat, okay, and let's just write P1 hat. And then we're going to do the same thing here because we're talking about sample statistics. P1 hat, or the proportion of those students that completed the task successfully that had a full night's sleep, is 0.780 versus this group here that was awake the whole night before. Okay, and 30% of those students were able to successfully complete the task. We also need to calculate the standard deviation or standard error of the mean. So it's just equal to this times 1 minus p hat divided by n. And we get this term, okay? And then we need to do the same thing for this sample, which is equal to p2 hat times 1 minus p2 hat divided by the sample size of 50. And so now we have these two components that will feed into a confidence interval equation that you have the difference of the proportions, okay, the sample proportions, that would be considered the point estimate, plus or minus z alpha over 2, times the square root of p1 hat times q1 hat over n1, plus p2 hat times q2 hat over n2, okay, which are these two terms right here. Okay, z alpha over 2, okay, this term right here for 90% is 1.6449. The standard error, which would be the sum of these two terms square rooted, is equal to square root, and we're just going to add this term and this term, and we now have that. And then our margin of error is simply the multiplication of these two terms, or these two numbers right here. So it's this times this. So 0.144 is our margin of error. So our point estimate, P1 hat minus P2 hat, is simply this 0.780 minus 0.3. So our point estimate is 0.480. And then if we go ahead and calculate our lower and upper bound of the confidence interval, it's 0.48 minus 144 and 0.48 plus 0.144, which means, and what we can infer, the proportion difference of math scores at a 90% level of confidence between students who got 8 hours of sleep versus those students that stayed awake the night before is between 34.34 or 34% to 0.62 or 62%. The next question is this statistically significant? I say yes, because this interval does not go through the 0 point, we have concluded that the difference of scores at this 90% level between students who got the sleep versus those that didn't, okay, again, proportion difference, the scores are 34% to 62%. That would be the bound of the difference. That concludes this video.